Hello everyone, myself Maruthi welcoming you all to this physics video session. Right, in this video I have taken a topic from chemical bonding and I am going to explain you how the bonding goes on, taking an example of one of the important types of chemical bonding, that is ionic bond. Okay, to get into the details, you know we are having 118 elements in the nature now. Right, in that few are stable, few are unstable. All right, few are very actively participating in chemical bonding, right? Few are inactive, right? Why? What is the reason behind that? Why they don't want to, why few of the elements they doesn't want to involve in the chemical reaction, but whereas others they are too actively participating in the chemical reaction, they are bonding with someone, they are combining with someone. What's the need? What's the reason behind that? So to know the reason behind that one, we have to think about the periodic table. Alright, so if you think about the periodic table, the 8th group elements, right there, all the elements are there whose outermost orbital is completely filled. Right, whatever the orbits they have, if the last orbit is completely filled, they are stable. They are chemically inactive. There is no need for them to go and bond with someone, right, to lose an electron or gain an electron. So that's the secret. Means out of the total 118 elements, few elements which are present in the 8th group, right, their outermost orbital is completely filled. Right, whereas the remaining all elements, that is from 1 to 7 elements, they try to lose electrons or gain electrons so that they too can have outermost orbital octet and they too can have outermost orbital completely filled. So the process of attaining stability, the process of getting octet configuration, the process of filling outermost orbital with 8 electrons, right, the process of getting that one is nothing but chemical bonding. Right, so let me explain you regarding that one. That's what he says. Right, the chemical activity which enables an element to attain octet configuration in the outermost shell and to get stability is called chemical bonding. That's what we said, right? We are talking about the chemical bonding, the process, the chemical activity which enables an element to get stability, to get 8 electrons in the outermost orbital, to fill outermost orbital completely with 8 electrons. This process is nothing but chemical bonding. Right, of course, the process of bonding may be different. The process of getting and losing electrons may be different from one another. Right, so those processes are nothing but chemical bondings. Right, the main two chemical bonds are nothing but ionic bond and covalent bond. Right, the process of attaining stability, there are mainly two types, ionic bond and covalent bond. So in this video, I am going to explain the process of ionic bond. Okay, so how it goes on, what are the properties of ionic bond, which one straightly shows interest, too active towards the ionic bond, what's that? Let us know. So if you are talking about ionic bond, if the bond is formed between two dissimilar elements, right, let me explain you clearly what are called dissimilar elements, metallic elements and non-metallic elements, right, their characters are entirely different, right, so that's what it says, metallic atoms and non-metallic atoms, they are of different properties, right, whereas these metallic atoms they are towards the left side of the periodic table. Okay, so they try to right, lose electron to get stability, right, whereas the elements present towards the right side of the periodic table, they want to gain electrons to get stability. Right, so there are two different characters, one is ready to lose and one is ready to gain. Right, if the chemical activity is going on between both of them by complete transfer of electron from one atom to another atom, these are metallic, these are non-metallic, they are different elements. One is losing the electron, the other one is gaining the electron. Right, if such a property is going on, right, if the bonding is going on by complete transfer of electron from one variety of element to the another variety of element, then we call it as ionic bond. Let's go for that. Right, the bond formed between two dissimilar elements, I have said dissimilar. Means few are metals, few are non-metal. They are having dissimilar properties. That's what. The bond formed between dissimilar elements by complete transfer. They are not going to just, if they lose it, they are done. They are completely transferring the electron. That a complete transfer of electron from atom of one element to another is called as ionic bond. So complete transfer of electrons takes place in ionic bond between two dissimilar elements. Right. So one type is nothing but metallic atoms, and they are combining with non-metallic atom. Of course, both metallic and non-metallic, they are trying to become stable. They are trying to become stable like inert gases. Okay, so what are all? If you take an example of non-metallic atoms, right, I said their outermost orbital is not completely filled. I can give an example of fluorine here. Fluorine, which is a non-metallic atom, fluorine, atomic number 9. So 2 electrons are in the first orbit and 7 electrons are in the second orbit. So second orbit, it does not have octet configuration. If it has 8 electrons in the outermost orbital, they are stable, they are completely filled. But here if you check it out, they are having 7 electrons. That's what the outermost orbit, which are nothing but the valence electrons, they are only 7. They try to gain 1 electron in the outermost orbit. So this is an example of non-metallic atoms. That's what, right? So now, so that's what he said. Metallic atoms, which we can call it as cations. Right, sodium, right, plus ion. So atomic number, we can say it as the sodium, it is having the configuration 2, 8, 1. 2, 8, 1. So here, right, the sodium we are talking about. In the same way, sodium 2, 8, 1 and the chlorine 2, 8, 7. Outermost orbital is not completely filled. It is having only 1 electron. Valence electrons are only 1. Whereas chlorine, outermost orbital is not completely filled. The outermost orbital is having 7 electrons. See here, 1 and 7. So this metallic atoms which are ready to form cations, they are ready to form cations. I have taken the example of sodium. They are ready to lose that 1 electron so that the non-metallic atoms will gain that, right, they will gain 1 electron and they will become anions. So this is what they both, sodium and chlorine, they combine together and form sodium chloride. So of course both sodium and chlorine are having octet configuration. Now they are stable. Right. So this is an example of ionic bond, but please remember, ionic bond is formed by complete transfer between two dissimilar elements, especially metallic atoms and non-metallic atoms. So now what are the properties of metallic atoms? How do they behave? I will go a little bit clear. And what are metallic and non-metallic atoms and how do they behave? I'll get back. Let us explain the properties of the metallic elements which are towards the left side of the periodic table. Right. So now metallic elements, right? 1A, 2A and 3A. If you think about this one, 1A, 2A and 3A. These 3 group elements are generally considered as metallic elements. Right. How do they behave? What is the general electronic configuration? We will get back to that one. So 1A, 2A and 3A group elements of the periodic table are having metallic properties. Right. They are having metallic properties. And please remember, right, as they are towards the left side of the periodic table, their general electronic configuration 1A, 2A and 3A, their general electronic configuration are NS1, NS2 and NS2 and P1. These are the general electronic configuration. So, but please remember, everything depends upon the stability. And when do they become stable? If the outermost orbital is completely filled. But if you check it out, the valence electrons of the first A group elements is nothing but 1, and the valence electrons of second A group elements is nothing but 2, and whereas the valence electrons of the third A group elements is nothing but 3. Means, please remember, if you have octet, that is 8 electrons in the outermost, if the valence electrons are 8, then only they become stable. So please, you have to calculate that 1A group elements are having valence electrons 1 and they are ready to lose that 1 electron. Why? Because getting 7 more to become 8 is not practically possible. So whereas second A group elements, they are having 2 To become 8, they need 6 more. So instead of getting 6, they are ready to lose 2. That's the secret. And whereas the third A group element, their valence electrons are 8. To make them completely filled, they need 8. Alright? Means to bring, they need to gain means they need 5 more, which is very difficult. So they are ready to, they will be willing to lose those 3 electrons. That's what he says. All they are left side of the periodic table and they are very highly unstable. They are not at all stable. They are too active, especially 1A group element alkaline metals. 1A group elements, alkaline metals are highly reactive. They are too eager to lose that 1 electron and become stable like nearby inert. Out of all these 3, the alkaline metals 1A group are highly inactive. They are ready too active to lose that 1 electron and become stable. That's what. Their outermost orbital is not completely filled. That's what. They don't have completely filled. Right. To attain that stability, to make a octet configuration in the outermost, they are ready to lose electron. 1A group element is ready to lose 1 electron, second A 2 and third A 3. Now to make you better understand, let me come back with another example. Sodium atomic number 11 and their electronic configuration 2, 8, 1. Outermost orbital only 1 electron. Magnesium 2, 8, 2. Outermost electron 2, valence electron 2. Aluminium 2, 8, 3. So please remember, so 1A group is ready to lose 1 electron. 1A group is ready to lose the outermost electron. 2A group is ready to lose 2 electrons. 3A group is ready to lose 3 electrons. If they lose those 1, 2, 3 respectively, what they become? They become what we call cations. Cations. Why? Because if you check it out, sodium atomic number 11. So how many electrons they lose? 1 electron they lost. If they lose 1 electron, they will be extra with 1 positive proton. So it is not an atom now, it is an ion. Unipositive ion. So which is this unipositive? All these positive ions, we call it as cations. I like to repeat. Sodium atomic number 11. 11 protons and 11 electrons, right? But it lost 1 electron. If it lose 1 electron, protons are 1 more. Right, therefore we call it as plus 1. 1A group plus 1. Whereas 2A group, it lost 2 electrons. Totally 2 protons are, 12 protons are there and it lost 2 electrons. Means total number of electrons are only 10. Means protons are 2 more. Therefore they become dipositive. In the same way, aluminium will become tripositive. All these are nothing but the cations. But please remember, all these cations here, if you lose 1 electron, it becomes 2, 8. The outermost orbital is having octets. If they lose these 2 electrons, the outermost orbital is having octet. Right. If you lose these 3 electrons, the outermost orbit will be having octet. So means all these examples of sodium, magnesium and aluminium, for them the nearby inert is neon. Therefore all of them, they got the inert gas electronic configuration as nearby inert element, which is for them it is neon. For the remaining group elements of second A and third A, whoever might be the nearby, right, they lose respective electrons, become cation and get the inert gas electronic configuration of nearby inert. So these are the properties of metallic elements which are towards the left side. Please remember, all these elements, they are forming cations. Yeah, let's talk about the non-metallic elements present on the towards the left side of the periodic table. Right, so in the periodic table, especially the 7A, 6A and 5A group elements of the periodic table we considered as non-metallic elements. That's what. So let's talk about this one. 7A, 6A and 5A group elements of the periodic table are non-metallic elements. So what are their properties? What is their need for them to become or participate in the ionic bonding is nothing but to get stability. So the outermost electronic configuration or the outermost orbital is not completely filled for these non-metallic elements, right? They are not completely filled. That means they are not having octet configuration. If they are having octet configuration, obviously they are stable. So as these guys are not having octet configuration, they try to get to stability by gaining the electrons. So how it is going on, let me tell you. Right, they are towards the right side of the periodic table. Yes, right. So they are towards the right side of the periodic table, the non-metallic elements. Right, their outermost orbital is not completely filled. To make you better understand, let us go for the group 7a, 6a and 5a. What we are talking about there. Their general electronic configurations are ns2, np, right, 5. Right, if you check it out, octet configuration is nothing but ns2, np6. If you check it out, it is less by 1 electron. It is less by 1 electron. Whereas, if you think about the valence electron, means the electrons present in the outermost orbit is nothing but totally we are having 7 electrons. So, but we know to become octet, it requires 1 more electron. Right, let's go for the 6a group element. It is nothing but ns2, right, np4. np4 means it requires 2 more electrons to become stable, but valence, it's nothing but valence electrons are nothing but 6 here. 2 plus 4, it's nothing but 6. Now if you go for 50a group elements, it's nothing but ns2, np3. Right, whereas it is having 5 electrons in the outermost orbit, means the valence electrons are 5. Right, so to make you better understand, let's come back to another example. 7a group element, it's the best example is nothing but chlorine. Alright, so if you are going for the stable electronic configuration 2, 8, 7. So this is K, this is L and this is M. Outermost orbit is not completely filled. It requires 1 more electron. Right, it requires 1 more electron. Whereas 6a group element, I have taken the example of sulfur. Sulfur, its outermost electronic configuration is 6. Outermost orbit is not completely filled. It requires 2 more electrons. Whereas if you go for phosphorus, whose atomic number is 15, outermost orbital or outermost orbit it is having 5 electrons. It requires 3 more. So this is the fact. So all these group elements, that is nothing but 7a, 6a and 5a, whose outermost orbital is not completely filled, they are highly active. Right, they want to gain 1 electron, whereas 7a group element wants to gain 1 electron, 6a group element wants to gain 2 electrons to become stable, to get octet configuration, whereas 5a group elements, they wants to gain 3 more electrons to fill outermost orbital with 8 electrons, so that they become stable. If they are stable, as you all know, they are no need for them to participate in any bonding if they are stable, if they get octet electronic configuration. So for that, so what's happening here? Right, these right, example of these, they lose 1 electron. 7a group elements, they gain 1 electron. So 7 plus 1, it becomes 8 here. Alright, 7, it gains 1 electron. So it gains 1 electron and becomes 8. Outermost orbital, it is having octet. But when it gains 1 electron, already atomic number is 17, means it has 17 protons, right? So 1 electron has come extra, means they are not having equal number of electrons and protons, means in this one 17 protons are there. In the same way, earlier they were having 17 electrons, but 1 electron is added, which is an extra one. Therefore, it's nothing but uni-negative ion. It's nothing but uni-negative ion. So, alright, in the same way, so outermost orbit is nothing but 8. If it is 2, 8, 8, it is nothing but it's 18. Inner, the nearby inner to that one is argon. So, chlorine Cl minus uni-negative ion is behaving like a nearby inert, which is nothing but argon, which is having outermost orbital completely filled with 8. Of course, the atomic number of argon is nothing but 18. Right. In the same way, right, the 6a group elements, we have taken the example of sulfur, right, to fill the outermost orbital with 8 electrons, it gains 2 electrons. It gains 2 electrons. When it gains 2 electrons, obviously it is becoming di-negative. Right, but earlier it is having 16 electrons, now 2 more are gained in the outermost, altogether it is having 18, like nearby inert argon. Alright, in the same way, if you go for phosphorus, it is gaining 3 electrons and it is becoming tri-negative. Right, so totally 15 plus 3, totally 18 electrons. It too is becoming like nearby inert. I have taken the example of chlorine, sulfur and phosphorus as an example. In the same way, the remaining all elements, whatever might be the nearby inert, they become that. But all the 7A group elements will gain 1 electron, 6A group elements will gain 2 electrons, and 5A group elements will gain 3 electrons. All these are negative ions. Therefore, we call them as anions. Right. In this way, all the 7A, 6A, 5A group elements are gaining 1 electron, 2 electron, 3 electrons respectively and becoming anions. That's what it is. To 18 octet configuration, they gain electrons and become negative ions called anions. So earlier we were talking about metallic atoms which became cations. Now we were talking about non-metallic elements which are becoming anion. So what's the reaction? What's the force which is pulling them together to make bonding? After the formation of cations and after the formation of anions, how the ionic bond is going on, what making them to come close, right, and get bonded and become stable. Let's come back to this one. So the cations, which are nothing but positive ions, right, anions, which are nothing but the negative ions, they combine together. Why they are combining means you are supposed to remember opposite charges attract each other. Right, one it is positively charged and the other is negative charge. The electrostatic force of attraction pulls them together, as they are oppositely charged. They come close and make up a bonding. That's what the point says. Cations positively charged, anions negative charge, they combine together to form an inert compound. Example, just now I said to you, sodium plus, right, Na plus which is a cation positively charged, Cl minus which is a negatively charged, right, ion, they combine together to form sodium chloride. Please remember, sodium chloride is an inert one which is a stable one. So this is the process of, in this way, as if sodium chloride is formed, in the same way we can come back with magnesium chloride, aluminium, other compounds. Basing upon the valency, they combine. But please remember, ionic bond is formed by complete transfer of electrons from one atom to another atom. In the same way, we are having few definitions. Here, the bonding is between two oppositely charged particles, ionic particles. So, as the bonding is between two ion particles, we can call it as ionic bond. That's what. As the bond is between ions, which are charged particles, we can call it as ionic bond. In the same way, the two ions are coming close because of the electrostatic force of attraction. Because of that, we can call this one as electrostatic bond also. That's what the point says. As the force of attraction between the atoms is electrostatic. What is the kind of force present? If you ask a question, what is the force which is pulling towards, is nothing but electrostatic. As it is electrostatic, we can call the ionic bond as electrostatic bond also. And moreover, the valence electrons are participating here more. Right, every outermost orbit is trying to get completely filled. So we are not talking about the inner electrons, we are talking about only the valence electron, whether it might be a cation or it might be an anion, whether it might be a metallic element, whether it might be a non-metallic element, which are participating, on which we are focusing more. It's nothing but the valence electron. As valence electrons are involved in this bonding, we can call it as electrovalent bond. Right, that's what the point says. As the valence electrons are involved, it is also called as electrovalent bond. So guys, ionic bond, which is one of the very important bond, but please remember, it forms between two different elements, making them stable. In this channel, I have been placing both math and science videos.